Good afternoon to all. We are starting the next topic of theory of computation, and that is nothing but the regular expression. So, the contents in this particular unit that we are going to discuss, these are the contents are definition and identities of a regular expression, right? The first topic that we are going to discuss. The second one is nothing but your construction of regular expressions of for the given language. Then construction of a language from a given regular expression means a regular expression is given and you have to describe that expression in terms of your English language. The construction of finite automata from the given regular expression using the direct method. Construct conversion of finite automata to regular expression using Ordinance theorem and pumping lemma, closure property of regular expression, and applications of regular expression. These are the topics that we are going to discuss in this particular unit. That is nothing but your regular expressions, right? So let us start with the definition and identities of regular expression. What is the definition of regular expression and which are the different identities? Okay, so we can say that it is very simple topic. You can understand it very quickly. There is a one can say there is no difficult topic as such in this particular unit. So let us see here, as we have discussed in the previous unit, the language accepted by finite automata they are known as the formal language. They are known as the formal language, right? And the regular languages can be precisely represented with the help of regular expression. Means now, what is the regular expression that we are going to see? But for the timing, remember that the languages which are represented by the regular expression, they are called as the regular languages. They are called as the regular languages. Getting this point? So, regular expression are used to represent certain set of strings in an argotic manner, right? So, every language contains some meaningful symbols or alphabet, some meaningful symbols or alphabet. The symbols that usually appear in a regular expression are the alphabet in set sigma, right? So in fact, a regular expression can be thought of as a mathematical model, of language representation, and finite automata can be considered to be a mechanical tools for representing a language. So as it is said that formal language, so automata, your finite automata describe the language, and that is called as the formal language. This particular language is called as the formal language. So finite automata is nothing but the mechanical tool. Means you can have representation in the form of states and transitions. You have the state q0, q1, and there is an input symbol, and in some cases there may be output symbol. So this is nothing but the representation of formal language in terms of graphical representation, and not in terms of mathematical representation. So but the same language can be represented in terms of your mathematical expression, mathematical models, or mathematical expression, and that is called as your regular expression. Getting this point or not? So finite automata, whether it is a DFA, whether it is a NFA, whether it is your automata with output, that is Millet or Moore machine. So all these are the machines that can be represented with the help of graphical representation, or the one can say that the mechanical tool. It is called as, that's why it is called as the mechanical tool. We can represent it in terms of your circles and arrows, transitions, right? But the same language can be represented in terms of mathematical models or in terms of mathematical tools. Now, which are the mathematical tools? So you have plus operator, it is called as you have the this multiplicator operator, you have the dot operator. So these are the operators. You have the parenthesis, so all these mathematical operators, these are all the mathematical operators we are going to use. And we have the input alphabets. You have input alphabet, that is nothing but sigma. It consists of a comma b, or sigma consists of 0 comma 1. So we have multiple any number of input alphabet. We have any that is nothing but a comma b or 0 comma 1, and we have the operators. We have the mathematical operators, so we can call it as a mathematical operators. And the same language can be represented by using this particular input alphabet, using this operator, and that is called as your regular expression. That is called as the regular expression. That's why it is said that regular expressions can be thought of as mathematical model of the language representation, whereas the automata can be considered to be a mechanical tools for representing the language. Getting this point? So how to define the regular expression, or how to write the regular expression? So for example, although the languages are best represented graphically, means in terms of just like automata, by finite automata, the regular expressions are more user friendly, means more user friendly and prove to be an attractive alternative to the finite automata. Just now we have discussed that, means particular language, you take a formal language, you take any, for example, regular expression 0 into 1 describes a language that contains all strings of any number of zeros ending with a single one. So this is nothing but the language description. This is nothing but the string, or this is nothing but a problem given in the language. Now you can draw a automata. You can have the states q0, you can have the q1, you can have the q2. You can draw, represent the same problem with the help of your finite automata. Represent the same problem with the help of your finite automata. That is nothing but your graphical representation. But now in this particular unit, we are not going to deal with the graphical representation, but we are dealing with the mathematical representation. Meaning is that we are going to use your plus operator, we are going to use your multiplication, we are going to use your dot operator, we are using parenthesis and so on. And we have this input alphabet either 0 comma 1 or a comma. And given problem of that particular language is represented in terms, and this is called as your regular expression. It is called as a regular expression, right? And this particular regular expression has some properties, has some identities that we are going to see. Identities of regular expression, that also we are going to discuss now, right? So yes, there are there are two ways for the representation. Yes, you can represent in terms of automata, means graphical representation, or you can represent in terms of regular expression, or more commonly it is called as RE. That is nothing but your regular expression. Getting this point? So see here, applications of regular expression. It can be used for the compiler design, that is lexical analyzer, the text searching, then pattern matching and speech recognition. So in all these four applications, the regular use of regular expression is there. That is in compiler design, then you have the text searching, then you have the pattern matching, and you have the speech recognition application, that is natural language processing is there. So you can use the regular expression, right? So formal definition of regular expression RE over the input alphabet sigma, we can define like this: any member, see carefully, any member of input alphabet sigma is called regular expression. We can represent regular expression as A, or you can represent as A or as small r, or even you can have capital RE, or you can have R equal to R. That is nothing but a regular expression. So any member of sigma, input sigma, is called regular expressions. For example, sigma equal to 0 comma 1, input alphabet is equal to 0 comma 1. So 0 is one regular expression and 1 is another regular expression. So there are two regular expressions. So I can write like this here: R equal to 0 as well as R equal to 1. So these are the two regular expressions. Getting this point? So we'll see one by one how to define regular expression over input set sigma. Next point is that phi. Phi is also regular expression which denotes the empty set. So your phi, it is also called as a regular expression, but it denotes the empty set, means there is a no symbol, one can say there is no symbol in that particular, as it is an empty set. Then sigma is a regular expression that denotes, epsilon. This is nothing but the sign of your epsilon is a regular expression that denotes the null string. Of course, there is a difference between the empty string and the null string. Phi is your empty string, whereas your epsilon. This epsilon represents your null string. Epsilon represents the null string, right? And both are the regular expression. The union of two regular expression, for example, R1 and R2, written as R1 plus R2, the symbol of union. This is the symbol for, remember, this is the symbol for union. So is also a regular expression. So if I have R equal to R1 plus R2, so if this R1 is a regular expression and R2 is a regular expression, then definitely R is also a regular expression, because I am taking here union of two regular expression, right? The concatenation or multiplication represented by the dot symbol here. So this dot symbol representation is nothing but your concatenation, right? So R1 dot R2 is also a regular expression. R1 dot R2, it is also a regular expression, right? Then closure or iteration. So closure means your R star. R star means it is nothing but, this is nothing but the closure property. R to the superscript, the closure sign, the star mark or asterisk mark, it is called as the closure property. The closure is nothing but the iteration. Closure stands for the iteration of regular expression R written in the format R star. It is also a regular expression. It is also a regular expression. R star, it is called as a clean closure, KLEENE closure of R. It is also called as a clean closure of R. It indicates, now what is its significance? It indicates any number of occurrences of R, including zero occurrences of R. So if I write here R star equal to, if I have to write here zero occurrence of R means what? It is empty string. Or I can write here epsilon, it is empty string, right? Empty string means I can have the null string, that is epsilon. Then one occurrence of R, then there are two occurrences of R, there are three occurrences R, or there are multiple, any number of occurrences of R are possible. Getting this point? Meaning is that this star indicates this empty string including zero occurrences and one as well as more occurrences. The significance of star or the iteration includes zero as well as any number of occurrences of that particular regular expression, and R star is also a regular expression. Getting this point? So just see it once again. So regular expression over input set sigma, it is described that any member of input set sigma, it is called as a regular expression. For example, if sigma equal to 0, 1, then 0 is also one regular expression and 1 is also one regular expression. Remember this point. Next point is phi, empty set is a regular expression. Then epsilon, the regular expression, it is the null string, is also a regular expression. If the two regular expression R1, R2, if you make the union of these two regular expression, union sign is by plus sign is union sign, then it is also a regular expression. If you want to concatenate or multiply two regular expression R1 dot R2, this is nothing but the concatenation or the multiplication. This is also resultant is also a regular expression. Then iteration, if you are taking the iteration, say for example R closure means R to the superscript, the asterisk mark or the star mark, that is also a regular expression. And the significance of R, it consists of your null string means epsilon, one occurrence of R, two occurrences of R, three occurrences of R, dot, any number of occurrences of R. This is the significance of R star, right? Now let us see, go to the next slide. Continue the definition of the regular expression R over input alphabet sigma. So the positive closure, now the previous one, it was the clean closure. Now here is the positive closure indicated by the plus sign, So that is nothing but R raised to plus. This is nothing but your R raised to plus. This R raised to plus is also a regular expression. It is defined as at least one occurrence of R. At least one occurrence of R means there must not be zero occurrence of R. Means there at least one R must be present. So if I have to write R plus, it consists of R, dot, like this way. So we can have, I can have this R plus is nothing but it is the positive closure. So it indicates there must be at least one occurrence. But in case of your R star, so there can be zero occurrence is also possible. So you can have epsilon, you can have R, you can have R, you can have one occurrence, two occurrences, three occurrences of R, dot, right? So in the meaning is that, so I can have R star equal to epsilon plus R, epsilon dot or epsilon plus R raised to plus. I can have, means your closure consists of your epsilon, means it is an empty string, and all other means positive closure of that particular regular expression. Getting this point? So positive closure of the expression is nothing but at least one occurrence must be there, or at least one occurrence of that particular regular expression is mandatory or compulsory. R is also a regular expression. Since regular expressions are mathematical notations used for the language representation, they follow same precedence rules as mathematical expression. Now, what is the precedence rules? Now we are saying that key regular expressions are mathematical notations, right? So all the mathematical rules, regular expression, they are the mathematical notations used for the language representation. That is the definition we have just now seen. So they must follow the same mathematical expression rules of precedence rules of the mathematical expression. Which are these rules? So these rules are nothing but, so first means when you start evaluating any expression in mathematics as well as in regular expression, you have to first give importance. This are priority to first parenthesis. Then second importance or the second priority is to the closure or the exponential operator. That is nothing but your star operator. The third priority or the third one can say importance is the concatenation or the multiplication, and the fourth one is the union operator or the addition operator. Getting this one? So we have suppose expression like this: a plus b, and then this plus operator or the sorry the curly bracket, they are having the highest priority. They must be solved first. Then it comes to be this vertical operator, that is nothing but your closure operator or the exponential operator. Then concatenation means, say for example, suppose multiplication is there, suppose dot a is here, so this multiplication or the concatenation operator is having next priority, and last priority is given to the union operator or the addition operator. So priority, highest priority to this operator, the next priority is to this, the next one is to the dot operator, and last priority is given to the plus operator or the union operator. Very similar to the in your mathematics, very similar just like in our mathematics. Getting this point? So just remember this. Now let us go to the next slide. We are again, now next point is nothing but the regular set. Now regular set means what? Any set represented by a regular expression is called the regular set. Means you have the regular expression, combination of such a regular expression, and you are forming a particular set. It is called as the regular set. That is called as the regular set. Now see here, consider the regular expression a comma b, which belongs to input alphabet sigma, then a regular set for a regular expression a, it is written as into curly bracket a. Then regular set for a regular expression a plus b, means it is a union operator a plus b, it is written as a comma b. Then regular set for the regular expressions a dot b, it is written as ab. Then regular set for regular expression a star, that is nothing but your closure property, or it is nothing but your closure star operator. That is nothing but, first is nothing but your epsilon, then single a must be there, then double a, triple a, and so on. Then regular set for regular expression a plus b star is. So a plus b star meaning is that you have two operators. This is the closure operator or the star operator, means any number of a and b's are possible, and this is or operator. Plus operator, union, or it is also called as the or operator, and dot operator is nothing but your and operator, just like in your logic design, right? So dot is nothing but your or and operator, and plus is nothing but your or operator. So a plus b, a is one regular expression, b is one regular expression. This is nothing but your mathematical operator. This is nothing but mathematical operator, or this operator is nothing but or. So this is the significance a or b. The significance of a plus b into bracket is meaning is that either a or b or both. So you can have a, you can have b, or you can have ab. Getting this point? This is the first significance. And the second point is that you are taking the closure of this particular bracket. You are taking the closure of the entire brackets. That's why. So you have the epsilon. So see here, you have the epsilon, you have the one occurrence of a, because or is nothing but you cannot, the b may not be there. So b is there. So meaning is that a may not be there. So double a is that means b is missing here. Double b is possible because a is missing. A b, yes, one a and b, it is also possible. Then then ba is also possible. A double b is also possible. So any number of a and b's are possible with the help of this a plus b bracket raised to star. A plus b bracket raised to star. Getting this point? So regular set for the regular expression a plus b, So this is nothing but your union or operator, and dot is nothing but your multiplication. That is nothing but your multiplication is nothing but and operator. Getting this point? Okay. Now let us go to the next slide. Now, very important. So all students see it carefully. You have to remember it. You have to by heart all the identities, because if you, until and unless you know the identities of regular expression, you cannot solve the problems on the regular expression. So to solve the regular expression problems, these identities must be understood by everyone, and it must be very clear. It must be very clear to all of you, right? So what is identities? So let us see here one by one. Consider the two regular expressions, capital P and capital Q. Consider two regular expressions, capital P and capital Q, are equivalent if P equal to Q. So if that means if P and Q represent the same set of string, if P and Q represent the same set of strings, now see here, let capital P, capital Q and capital R are regular expressions. Then the identity rules. Now these rules are given here: I1, I2, I3, I4, I5, I6, I7, and the rules are continued on the next slide also. Now let us see rule one by one. Now identity rule 1. See carefully. Identity rule 1 says that phi plus regular R is regular expression. So see here, P is one regular expression, Q is one regular expression, and R is another regular expression. Capital P, capital Q, and capital R. So phi is nothing but your empty string. So meaning is that empty string union regular expression gives you regular expression. Getting this point? So remember the first rule. So identities are, these are the rules of regular expression. These are the rules of regular expression. So you have to remember this. So empty string union or concatenate empty string with or operator, or this is nothing but your union operator with the regular expression, that always give you the regular expression. This is the rule. You have to remember this. Phi dot R equal to R dot phi, that is equal to R. Again, means empty string multiplied by regular expression, that is equal to regular expression multiplied by empty string, that is equal to R. This is the third rule, or this is the third identity of the regular expression. Next one is now epsilon. Epsilon is your null string. Epsilon is nothing but your null string. Dot R means multiplication to regular expression, that is equal to R dot epsilon is also equal to this thing, therefore that is equal to R itself. Means you are multiplying or you are adding. So here also addition with the null string, that gives you R. So from these four rule, from these four identities, it is clear that whether you are adding with empty string or null string, or you are multiplying with empty string or null string, you are getting regular expression itself. Means regular expression, you are going to add or multiply, you are going to plus or dot, you are going to plus or dot with the regular expression, the final answer you are getting is equal to your regular expression itself. Getting this point? So phi plus R equal to R, phi dot R equal to R, epsilon dot R equal to R, and epsilon plus R equal to R itself. Okay. Now this fifth one is nothing but unity R plus R equal to R. Regular expression, one regular expression, another regular expression, adding two regular expressions, that gives you R itself. The next rule, that is I6 rule, R dot R raised to star, means R dot R raised to R closure, that is equal to R closure dot R. You can also rewrite in this way, that is equal to R plus, that is equal to R raised to positive closure of this. Why? Because why this is because this R dot R raised to star dot R is equal to R plus, right? Then seventh rule, or the seventh identity, is that R raised to star bracket raised to star, means closure, R closure to the bracket closure, that is equal is equivalent to R closure, is equivalent to R closure. Getting this point? So remember these identities, these require to solve all the regular expression problems. These identities we require in the subsequent problems. Remember, so phi plus R, that is equal to R, phi dot R equal to R, then epsilon dot R equal to R, epsilon plus R is equal to R, R plus R equal to R, R dot R raised to star equal to R plus R raised to plus, then R star bracket star equal to R star, right? Now let us see the next identities. Identity number 8, identity number 9, 10, I11, I12, I13, I14, I15, and I16. Let us see one by one. So see here, R raised to star, regular expression raised to star means clean closure or the closure of R dot closure of R, that gives you closure of R finally. Then see here, epsilon plus R dot. So if there is no sign, so you have to assume it is a star. Sorry, it is a dot. So if it is R, it is written. So there must be dot. Means it is nothing but the dot operator, or it is nothing but the multiplication. So this is the case. So R dot R raised to star is equal to R star finally. So this entity we have to use many times in our example. Remember this, epsilon plus R dot R raised to star, that is equal to R star itself. So now second rule or the next rule, I10th identity is P plus Q bracket complete dot R. So P plus Q into bracket P plus Q bracket complete outside is R, that is equal to PR, means it is a multiplicative rule, plus QR, means you can have this union operator and this is the P dot R and Q dot R, P dot R plus Q dot R, right? Next identity or the next rule, P plus Q into bracket P plus Q bracket raised to star. Bracket raised to star means the closure of that particular bracket, that is equal to P star. See here, it is very important. P star dot Q star, that equal to P star plus Q star bracket raised to star. This is again important rule you have to remember always. So in case of regular expression, if this P is one regular expression and you are taking union of two regular expression P plus Q, and there is a bracket, and to this bracket you are taking their closure of this union, then you can have this P star dot Q star bracket complete, that is also equal to P star plus Q star bracket raised to star. And why it is this is the rule, these are the all identities, we can call it as identities of regular expression, or you can call it as a rules, thumb rules, we can call it as a thumb rules. And while solving the examples, we have to use all these thumb rules, remember this one. Then R star dot into bracket R plus epsilon, that is equal to, you can also rewrite it into bracket epsilon plus R dot R raised to star, that is equal to R star only. Means if in the example, or if this term is there, if such type of term is there, so you can replace this entire term with this R star, because these two are equivalent, here, right? Next identity is I13, R plus epsilon bracket raised to star, that is equal to R star. Again important one, suppose you are adding the regular expression with, you are taking a union operator, or it is nothing but your OR operator with regular with the empty string epsilon and bracket raised to star, that is nothing but your R raised to star, or it is nothing but the R closure, right? The next one is your next entity, next rule is I14, P Q into bracket P dot Q bracket raised to star, then dot P, that is equal to P dot into bracket QP, means you can have this type of arrangement of regular expression also. Then R star dot R plus R, that is equal to R star dot R, means you can have this instead of 3, R star dot R plus R is equal to R star dot R. Next one is nothing but your P dot Q into outside the bracket dot R, that is equal to P into bracket dot into bracket Q dot R. This is there. So remember all these total 16 identities or the 16 rules. So number 8, number 9, number 10, rule number 11, rule number 12, rule number 13, rule number 14, rule number 15, and the final is the rule number 16. So remember this, right? So that we can solve the problems on the which are based on the regular expressions, right? So see here the problems which are based on the equivalence of two regular expressions, So equivalence of regular expressions, two regular expressions means what? This is your left hand side of the regular expression is given, and this is the right hand side of the regular expression is given. So you have to prove that LHS that is equal to RHS. You have to prove this LHS equal to RHS. And while proving this, we have to use the identities, which just now we have seen the rules of identities, or the identity rule we have to use here. And using this identity rule, so one thing that can be replaced, or so that we can try to manage, or we can prove easily that left hand side is equal to right hand side. That we have to see here, that we have to prove here, right? So see how it is being proved. So the on the left hand side it is given here 1 into bracket 1 plus 0 0 raised to star 1 bracket complete plus the union operator 1 plus 0 0 raised to star 1 in bracket complete, next bracket 0 plus 1 0 star 1 bracket complete, bracket raised to star another bracket 0 plus 1 0 raised to star 1 bracket complete, that is equal to 0 star dot. If there is no sign means it is a dot, always remember. Dot 1 into bracket means again here is a dot into bracket 0 plus 1 dot 0 raised to star dot 1 bracket complete raised to star. So start proving this. So first let us solve left hand side first, that is LHS of the equation. LHS of the equation is written as 1 plus, so whatever may be the left hand side term, just write this term here. So what common factor you find here? So this is there, this is the first and this is the second. Uh, we can have this thing on the left hand side of the plus operator and the right hand side of the plus operator. So you can find 1 plus 0 0 raised to star 1, and this term is also here 1 plus 0 0 raised to star 1, this term is here. So we can take common from this particular term as a common factor, so that we will get the term like this. So if we take this term as a common, so we get this is the common term dot into bracket. So instead of this you have this epsilon, you have the epsilon here, because now empty string, because the you have taken this string common here, plus these two terms 0 1 0 plus 1 0 raised to star 1 bracket star dot 0 plus 1 0 raised to star 1 bracket complete and bracket complete. Getting this point? This is clear to all of you. Now next, now we have to apply the identity rule. So identity rule, so now we can have, or we can see that epsilon plus r raised to star dot r, where r is nothing but, what is the value of r? R is nothing but this one, 0 plus 1 0 raised to star dot 1. This is the value of your r, this is the value of your r. Getting this point? This is becomes your r value, right? So what is the rule? So rule says that, as we know that epsilon plus r raised to star dot r equal to epsilon plus r dot r raised to star, that is equal to r star. Means we can write this is our term we can have. So this term we can replace, this entire term we can replace by this one 0, because this is your r now, 0 plus 1 0 raised to star dot 1 raised to star. Getting this point? How this, and this term is as it is here, this term as it is here, and this entire term, because here r is this one is called as r. Now you can compare this, you can compare. So epsilon plus r raised to star r, meaning r, and r is nothing but this. So what is the answer to this entity? Answer to this entity, epsilon plus r dot r raised to star is equal to r star. So I can replace this entire term with this r star, right? So see here, the next step, we will take 1 as a common factor. Now from these two entities, we take 1 as a common here. So after taking 1 as a common, what we'll get here? So after taking 1 as a common here, instead of 1 I put here epsilon 0 0 0 0 raised to star as it is, and 1 is removed and it is taken here. So here no, so from here you can take 1 common. So it is so we have taken 1 common to this particular thing. From this particular equation we have taken 1 common dot here, and this term is as it is, this particular second term remains as it is, right? So see here, applying epsilon, apply again second entity. Now that's why I told you that entities are very important. So you have to understand the entity rules, identity rules, so that this, now see here, epsilon plus 0 dot 0 raised to star, that equal to 0 raised to star. So we can write, so this term we can write, it is nothing but your 0 raised to star. So you see here 0 raised to star dot 1 dot, the rest of the term is as it is, and that is nothing but your RHS. Now look at this RHS, look at the RHS, 0 raised to star dot 1 into bracket 0 plus 1 dot 0 star dot 1 bracket complete raised to star, this is nothing but your RHS. Hence, the two regular expressions which are on the LHS and RHS, they are equal. We have proved it with the help of our identity rule. So we have used this rule, identity rule here, and the second identity rule we have used here. These two, one and second two identity rules of the regular expression we have used here. Getting this point? So this is the way how we are solving the problems. This is the equivalence problem. Means we have to check whether the two regular expressions are equivalent or not. That we have check here, right? Now let us see the another example. Second example, show that a simple example or the simple regular expression on both the sides. 0 star dot 1 bracket raised to star equal to 0 plus 1 bracket raised to star. It is given here. Now consider the LHS. Now LHS is 0 star dot 1 star raised to star bracket raised to star. So here star is missing, I think. So you can have, so what is the possible strings are here? So 0 star, 1 star and bracket raised to star. So possible strings are epsilon, means you can have the empty string, you can have one occurrence of 0, you can have one occurrence of 1, okay. Then you can have two occurrences of zeros, you can have two occurrences of 1, you can have 0 1, you can have 1 0 is possible, you can have triple 1, you can have triple 0. So like this way, these are, so this is nothing but the, this is nothing but your set of strings. See here, this is nothing but your set of strings which is given by this particular left hand side operator. And see here, so that is nothing but how you can describe it. So epsilon, so any combination of 0, yes, any combination of 0 means it can be 0, it can be 0 0, it can be 0 triple 0, any, or any combination of ones means 1 double 1, you can have triple 1, anything, or any combination of 0 1 means 1 0, you can have 0 1, you can have 1 1 0, or you can have 0 1 1, or you can have 1 0 0, or you can have 0 0 1. So any combination of 0 and 1 are possible. Means this set, means this particular left hand side can be written. So how many strings, how which are the different possible string given by this left hand side, so 0 double 0 1 double 1 triple 1 0 1 1 0, meaning is that I can have epsilon, I can have any combination of 0, or I can have any combination of 1, or I can have any combination of 0 and 1, any combination of 0 and 1. So similarly for the right hand side, now take the right hand side regular expression on right hand side, it is nothing but 0 plus 1 bracket raised to star, 0 plus 1 bracket raised to star. So 0 plus 1 means what? It is nothing but your epsilon. Just now we have seen it is nothing but epsilon. One occurrence of 0, one occurrence of 1, then two occurrences of 0, two occurrences of 1, then three occurrences of 1, you can have 0 1, you can have 1 0. This 0, this plus is nothing but your or operator, this is nothing but your or it is called as the union operator, right? Already we have discussed this, right? Means either 0 or 1 or both. So you can have 0, you can have 1, or you can have 0 1, and this is having its closure, this is having its closure. So 0 0 occurrence of 0 is nothing but your epsilon, and 1 occurrence of 0 is nothing but your 0. Now 1 to the bracket is star. Now 0 occurrence of 1 is nothing but epsilon, it is already there, and 1 occurrence of 1 is nothing but 1, right? Then 0 1 raised to 0 1 bracket raised to star, right? So 0 1, 0 occurrence of 1 0 0 1 is nothing but epsilon, which is already written. 1 occurrence of 0 is nothing but 1 0 1. Getting this? So how the strings are being formed here? So regular expression, so right hand side of regular expression, how the these are the strings. Remember, these are all the possible strings. These are called as the all possible strings given by your regular expression. These are all possible strings that are given by the regular expression. So we write this is the set of strings. We can say that it is nothing but the set of all possible strings given by this particular regular expression, right? So meaning is that, so how I can describe in English language? In English language, I can describe it is nothing but the epsilon. Yes, it is epsilon. Any combination of 0. Yes, it is. It consists of any combination of 0. Also, it consists of any combination of 1s. Yes, correct. And it also has any combination of 0s and 1. It also has any combination of 0s and 1. So I can write here, hence LHS that is equal to RHS. So from these two terms, from this description and this description of LHS and RHS, so meaning is that both the regular expression on left hand side as well as on the right hand side, they generate they generate the same set of strings. They generate the same set of strings. That's why they are called as a equivalent to each other. Getting this point? Meaning is that the strings generated by this particular RE and the set of strings, more correctly, generated by this regular expression, they are equal. That's why these two regular expressions are equal. Getting this point? Okay. Let us go to the next example. Show that a plus b bracket raised to star that is not equal to a star dot b star. Now here you have to prove that these two regular expressions, they are not equal. They are not equal. Now the same method, consider the LHS that is equal to a dot b bracket raised to star. So how many strings, which are the different string it can give? So it can give me epsilon, that is nothing but, as it is a star means it is an empty string must be there. Then AB, because it is a dot operator. Dot means what? A and B, they are now one term. They are now one term because it is not a plus operator. If it is a plus operator, A plus B, then it can have either A or it can have either B, or you can have AB. This is possible in case of your plus operator. But here, what is which operator? Dot operator. Dot operator means yes, that is a multiplication, or it is a concatenation operator, or it is an AND operator. AND means A and B. So always A and B there. So A and B and its closure and its clean closure. So A and B, single occurrence of AB, then AB, AB, then AB, AB, AB. Then you can have AB, 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 AB in this way, in this particular format, right? But if it would have that A plus B, plus means it is a OR operator. Means either you have A, either you have A, or you have B, B, or B. If it would have been plus operator because it is an OR operator. Getting this point. So, but here is a dot operator, A dot B. AB means, though it is not given, but we have to assume it is a dot operator, AB, and it is nothing but your AND operator. AND means it is a multiplication operator, and both the terms are compulsory. But in case of B, A plus B, either you can have A or either you can have B. Remember this thing because these things are very important and they require for this regular expression, right? So we have find out our LSS string. So this is nothing but the set of all possible strings from the left hand side regular expression, and the same way, and the RHS A star dot B star. Now here A star dot B star. A star means, what is the meaning of A star? Means either 0 or more than 0 A, and B star means either it is 0 or more than 1 B. Meaning is that is equal to epsilon, yes, A, double A, triple A, then you can have B. Means B means what? What is the significance of A here? Can you tell me? Significance of A meaning is that B, there is 0 occurrence of B. Getting this point or not? Means this term is like this: A dot B raised to 0, meaning is that B 0 here. Means it is a 0 occurrence of B and there is 1 occurrence of A. Now this term B means it is nothing but A raised to 0, and B means the 0 occurrence of B and there is 1 occurrence of 0 occurrence of A, sorry, and 1 occurrence of B. Getting this point? And so for example, double A. So double A indicates that there are 2 occurrences of A and there is 0 occurrence of B. Means I can have A raised to 2 and B raised to 0. That is nothing but your double A only, and B is now 0. B terms is now absent here, or B occurrence of B is 0. But in this case, a double BA, occurrence of A is 0. Occurrence of A is 0 and occurrence of B is 2. Getting this point? So what we are discussing, star operator, that's why the star operator or the closure operator is very much important. Means it can have your 0 occurrence, means epsilon, empty string, right? Or it can have 1 occurrence, or it can have 2 occurrence, or it can have 3 occurrences, right? So, but this is nothing but A dot B, and A also star and B also star. So A also star and B also star, in the sense that either you can have A, so B is 0, or you can have double A, again B is 0, or you can have triple A where you are keeping B as a 0, right? Or you can make A as a 0, means 0 occurrence of A means you have B. Again 0 occurrence of A means you can have double B because there is a star symbol, and again there is 0 occurrence of A means triple B. So you have the string like this: A, double A, triple A. You have the B, BB, triple B. Or you can also have 1 occurrence of A and 1 occurrence of B. What will be the string for single occurrence of A and B? Single occurrence of A and single occurrence of B. Getting this point? Double occurrence of A and double occurrence. So double occurrence of A and double occurrence of B. Triple occurrence of A and triple occurrence of B. These are the strings. So these are all, we can say that this is nothing but the set of all possible strings. Set of all possible strings given by regular expression, that is nothing but your A star dot B star. Remember this point. This is very important. Remember and see it carefully, listen it carefully. So this is nothing but all possible strings. This is just written in a curly bracket. This is written in a curly bracket, right? So can we compare these things? So this is the set of all possible string. So this is your right hand side set of string, and this is your LHS set of string. So you have to compare this LHS and RHS. So can you find any difference? So can you find both are same, or is there any difference? Yes, there is a difference between these two set of strings here. So what is the difference? So note that. So in LHS, in the given LHS, the regular expression will give the strings of AB combination, because here AB only, A dot B. So all terms must be have AB, 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 AB only. So these the strings are in this format only. But what is the case in RHS? But in case of RHS, there is a possibility of AB. There is only a single term AB will be there, but not AB AB. There must not be any AB AB, or there must not be this AB AB AB. This term is not available in the second set. This term is also not available. But yes, this term is available. So we can say that these two, as the sets are not equal, the regular expression also are not equal. So we can conclude that thus LHS is not equal to RHS is proved for this particular regular expression. Getting this point? Okay. Let us go to the next example. Fourth example, show that R plus S bracket raised to star is not equal to, R star plus S star. So these are the two operators. This is your OR operator, or one can say that is a union operator. Here R or S. So I can read like this: R or S bracket raised to star, that is equal to R star or S star, right? So again the same method. So consider the LHS and find out the strings, possible set of strings given by the LHS regular expression, the regular expression which is on LHS. So R or S, I can have R, I can have S, I can have double R, I can have double S, I can have RS, I can have SR, RS, this way. And so this is nothing but empty string. Any combination of R and S, any combination of R and S along with the empty string is possible. But what is the case of right hand side? On right hand side, if I expand this regular expression into the set of strings, if I expand this regular expression on the right hand side into the set of strings, I will get, this is one string, the second string is R, third string is double R, then next string is triple R, next is S, double S, and so on. So meaning is, so the conclusion is that any combination of only R or any combination of only S, so only R and only S, but there is a no RS, this term is not there, which is here, this RS or SR, RS. You will not find RS here, right? So I can write the conclusion that in RHS there is no combination of R and S together. That's why LHS is not equal to RHS, which is given in the problem statement. It is proved, which is given in the problem statement. It is proved, right? Next, number 5, prove that. Now this is two regular expression. Now regular expression given on the left hand side is this, and on the right hand side is this. We have to compare this. So see the step by step method of evaluation. See here, let us consider the LHS term first. Epsilon plus 1 raised to star dot into bracket 0 1 1 star dot. So if the symbol is not, so if there is no sign is given, so it is, we have to consider it as a dot operator. So into bracket 1 star into bracket 0 1 1 bracket raised to star, bracket complete raised to star. So try to solve this. So if we consider 1, so consider this term 1 raised to star 0 1 1 star, consider this much term, and it call it as a P1 and call it as a P1. So we can write like this. So this term can be written like this, epsilon as it is plus, epsilon plus. So this term it is called as the P1, This is P1 and this is nothing but P raised to star because this is the star symbol. This is the star symbol. So P1 raised to star, right? So P1, so this is, so from entity, so this term is now epsilon plus P1 dot P1 raised to star, that is equal to P1 star. And how this answer comes here? This answer is because we know the entity epsilon plus, and that is nothing but your epsilon plus R dot R raised to star, that gives you R raised to star. This is our entity. So the same entity is applied here, the same rule is applied here, and we get the answer P raised to P1 raised to star. And what is the P1 value? P1 is nothing but this 1 star dot into bracket 0 1 1 bracket raised to star. Getting this point? Now next step. Now we can put, now again this term is 1 star into bracket 0 1 1 star. So you assume so in this also we can put P1 equal to this term. Then we can have, so P1 star means the bracket raised to star. This this value is of P1, and raised to star means this P1 raised to star. So now consider this one as a P2, this one as a P2, consider this one as a P2, and 0 1 1 as P3. Consider this P2 1 as a P2 and 0 1 as a P3. Then it becomes, see, P2 1 star means your P2 star dot P3 star. This 0 1 1 is now P3 star is as it is, and this star is as it is here. So this becomes P2 star dot P3 star bracket raised to star. Now apply the identity rule. Now you just tell me which identity rule we have to use here. The rule which we are using here is nothing but your P star dot Q star bracket raised to star, that is equal to P plus Q bracket raised to star. So what is the value of P? So write down P2 plus P3 bracket raised to star. This identity rule we used here. The first identity rule is nothing but this one. That is, now what is the value of P? P is nothing but 1. And what is the value of P3? Sorry, P2 is nothing but 1. P3 is nothing but 0 1 1. So it is written here. So that is nothing but your RHS. Now, so look at the RHS term, the same RHS term. So we have solved the equation. We have start solving the equation from the left hand side, and we get the right hand side correctly. Getting this point? So we can have thus LHS equal to RHS is proved here. Getting this point? So in this way, we have to solve the equivalence of the. We have to find out the equivalence of the two regular expression with the help of the identity rules of the regular expression, right? Okay, so with the conclusion, in the today's session, we have discussed the definition and identities of regular expression, various identity rules of regular expression. Total 16 rules are there. We have to by heart all these rules, remember all these rules, because these rules are very much important and they are required. And next point that we have seen a few examples or the few problems on equivalence of regular expressions. The on right hand side and the left hand side expressions are given. We have to check whether the expressions, regular expressions, are equivalent or not. These two topics we have covered in the today's session. So course outcome attainment of the session is nothing but the construct the finite state machine, solve the problems, then this. So let us stop here for the today's session.
ठीक आहे शेड